Hey students, today we will be covering paper 4 of 2025, February-March. It's the latest paper, so let's start it. Question number 1. Using numbers only state the percentage of oxygen in clean dry air. So percentage of oxygen in clean dry air is 21%. Typical operating temperature in degrees Celsius used in Haber's process. So the temperature which is used in Haber's process is optimum temperature of 450. Then the number of atoms in a diatomic molecule. So in a diatomic molecule, di means 2. So the number of atoms in this molecule will be 2. Maximum number of electrons in the second electron shell of an atom. So the second electron shell contains maximum 8 electrons. So the electronic configuration is like 2 electrons come in the first shell, 8 electrons in the second shell, 8 electrons in the third shell. The number of hydrogen atoms in an alkane with 7 carbon atoms. So alkane with 7 carbon atoms, it will follow the general formula CnH2n plus 2. So if we substitute 7 instead of this n, because there are 7 carbon atoms, so H2, 7 plus 2, it comes out to be 7 into 2, 14, plus 2, 16. So there are total 16 hydrogen atoms in a molecule of alkane, CnH, C7H16. Then the number of particles in 1 mole in standard form. So in every 1 mole of a substance, there are 6.02 into 10 power 23 particles are present. So this is the Avogadro's number of particles present in every 1 mole of a substance. Next question is, this question is about ionic compounds. State what is meant by the term ionic compound. So what is an ionic compound? Well, right, that ionic compound is a strong force of attraction, or strong um, attraction which is present between the oppositely charged ions. So it is strong electrostatic attraction between oppositely charged ions, between the cations and the anions. Potassium sulfate is an ionic compound. Complete the dot and cross diagram for the ions of in potassium sulfide. So we have here potassium and sulfur. So 2 potassium and 1 sulfur. So we have to see in potassium, there are total 19 electrons. So its configuration will be 2, 8, 8, 1. And for sulfur, it has 16 total electrons. So its configuration will be 2, 8, and 6. For potassium, if you see clearly, then potassium has 1 electron in its outer shell. So it will lose that electron to become positively charged. Positive 1. And for sulfur, it has 6 electrons in the outer shell. So it can gain 2 electrons to become 2 minus and to complete its outermost shell. So sulfide ion is 2 minus and potassium ion is positive. Potassium's last shell with 1 electron will be finished because it has lost 1 electron. So its last shell will be finished. We will draw the last shell, the third shell of potassium, because the 2 shells are already drawn here. We'll draw the third shell with 8 electrons. Complete. 4, 5, 6, 7, and 8. Similarly, we'll draw the next potassium also with 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. As for the sulfur, it has total 6 electrons in the third shell. 1, 2, 3, 4, 5, 6. So 6 crosses. And it has gained 2 electrons, one from one potassium, the other from the other potassium. We'll draw them with dot. So this is sulfide ion. The ionic compounds form giant ionic lattices. Figure shows a part of giant ionic lattice structure of sodium chloride. Complete the diagram to show the ions present. Use positive for sodium ions and negative for chloride ions. One chloride ion has been completed for you. So this is one chloride ion which is already completed with a minus charge. Now, and with minus, the positive will be there. With positive, negative. With negative, positive. Again, with because opposite, this is an ionic compound, ionic lattice, so the positive charges will be together. The opposite charges, sorry. So with positive, negative, with negative, positive, with positive, negative. State the name given to any positive ion. So the positive ions are called cations. Ionic compounds can be decomposed by the passage of electric current using inert electrodes. State the name of this process. So ionic compounds are broken down or decomposed by the passage of electric current. This process is called electrolysis. Write the ionic half equation for the reaction which takes place at the anode when the molten potassium bromide is decomposed by the passage of an electric current. Very easy. We have molten potassium bromide, means it will give only potassium ion and bromide ion. They're asking us about the anode, which is already positively charged. So bromide ions, the negative ions, will go to the anode. And we have to write the ionic equation for the bromide ion. It will be 2Br negative will become Br2 after losing 2 electrons. Because the negative ions have this negative ions have a negative charge, which means that they have extra electron or electrons which they want to lose. So the negative ions always lose the electron. So with the bromide ion loses 2 electrons to become Br2, as bromine is a diatomic molecule. Next question. Name the products. Okay, so we have to name the products. State the observation at the negative and the positive electrodes when dilute aqueous potassium bromide is decomposed by the passage of an electric current. So we have here dilute aqueous potassium bromide, and we have to see what will form at the negative electrode and what will form at the positive electrode. For this type of question, first I suggest my students to write the ions. Like for potassium bromide, from potassium bromide, we'll get K positive and Br negative. These are the ions from potassium bromide. And from aqueous, we have H positive and OH negative. Then, if we want to identify that which ion will discharge at the negative electrode, we will see the reactivity of the 2 positive ions. The one which is less reactive will go to the cathode and discharge. Here, from potassium and hydrogen, the less reactive is hydrogen. So hydrogen will go at the negative electrode and will form hydrogen gas. So hydrogen will be formed at the negative electrode, and the observation will be the bubbles of colorless gas. As for the negative electrode, we'll see from bromide and hydroxide which one will go at the anode. For this, we will see that whether it is dilute or concentrated. As the solution is dilute, which means the hydroxide ions will be more in amount, hydroxide ions will discharge at the anode, and when they discharge at the anode, they form oxygen gas and oxygen gas and water molecule. This is the equation. When hydroxide ions discharge at the anode, they will be 4 OH negative, will give 4 electrons and form O2 plus 2 water molecules. This is the equation. So oxygen and water, these are the two products of this reaction. So we'll write them here. Oxygen is formed and water. Observations at the positive electrode. Now the observation will be the same, that it will form the bubbles of a colorless gas. Next question is about halogens. The halogens are the group of elements in the periodic table. Chlorine is a member of this group. State the group number of halogens. Now halogens are group 7. State how many halogens are there in this group. How many halogens are present? We can see from the periodic table. There is a periodic table in the end. Okay. Now this is the periodic table and these are the halogens. So we'll see there is fluorine, chlorine, bromine, iodine, astatine, tennessine. So 1, 2, 3, 4, 5, 6. There are 6 total elements in halogens. So we'll write here 6. Suggest the identity of the halogen which has the highest density and the most reactive. So we have fluorine, chlorine, bromine, iodine, astatine, and tennessine. These are the elements. Now fluorine is the most reactive because it has small, its size is small, the force of attraction and the force of repulsion is less. So the incoming electron will adjust itself easily because fluorine is a non-metal. Fluorine and all the halogens are non-metal, so they have to gain an electron to complete their outermost shell. So the easier to gain the electron will be in fluorine because of its small size and less force of attraction and less force of repulsion also. So the highest reactivity will be of fluorine and the highest density will be of the last element, which is tennessine. Because tennessine has a large structure, large atomic size. And it's solid also, so it must be heavier. State the name of the negative ions formed by halogens. So the negative ions which are formed by the halogens are called halide ions. State how many occupied electron shells are there in bromine atom. To identify the number of electron shells, we have to see that in which period bromine is present, because the period number tells us the number of occupied electron shells. So if we go to the periodic table again, then here, this is the first period of which contains only hydrogen and helium. This is the first period, then fluorine is present in the second period, chlorine is present in the third period, and bromine is present in the fourth period. So, if bromine is present in the fourth period, it means its number of occupied shells will also be 4. It has 4 occupied shells. So, we'll write here 4. Name the noble gas which has the same configuration as bromide ion. So after bromide ion, there is krypton. Because when the elements form ions, they attain the configuration of the nearest noble gas. So bromine has atomic mass 35. So after gaining 1 electron, when it becomes bromide ion, it becomes 36. Its electrons will become 36. And 36 is the atomic number of krypton. So it becomes like it attains the configuration like krypton. Aqueous chlorine reacts with aqueous potassium iodide. One of the products formed is iodine. Complete and balance the ionic equation for the reaction between chlorine and iodide ions. State symbols are not required. Now, as this is a displacement reaction, so for the chlorine molecule, it becomes chloride ion, it becomes Cl negative. And to balance, we'll write 2 and 2 here. Explain why this reaction is defined as the redox reaction. Give your answer in terms of electron transfer. Now, why this is a redox reaction? Because as you can see here that chlorine is becoming chloride ion after gaining an electron, and iodide ion is becoming iodine after losing the electron. It loses the electron. So there is oxidation happening and reduction also happening. The gain of electron is called reduction. The loss of electron is called oxidation. So this is a redox reaction because of this. The answer will be because the iodide ion loses electron and gets oxidized. Then chlorine atom gains electron and gets reduced. So that's why it is a redox reaction. Give the color and state of iodine at room temperature and pressure. Now, iodine state is solid. It's a solid, and the color of iodine is gray-black. We have done first 3 questions. Now, for the question number 4, 5, and 6, you have to see the next video. Thank you.